how I would use a spreadsheet to do some things in lesson 3.2. So I had already typed in earlier for that first guy we're looking at that he had 3 drinks, his weight was 120, and he was a male, so he gets the 0.68 number. And then I'll just show again how I calculated this number. Since it's a fraction with more than one thing in the numerator, you should put a parentheses, and then I have the 2.84 number times, and the drinks are right on the screen, so I just click on them, and the computer says, you clicked in cell B1. And I say, yes, I did. Then I close the numerator, multiply with the asterisk, and the denominator needs parentheses because it's more than one thing, and then I just click on the weight, asterisk to multiply, and then click on the gender, and then close the parentheses. And I made a mistake. I'm not multiplying here, am I? I'm dividing. Oops, slash for divide. Cool thing about clicking on things on the screen, if somebody says, no, 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 it's 4 drinks, I can just go up here and change the 3 to a 4, and it updates my calculation automatically. Just kind of cool. All right. So the next thing I want to do is build that table we were doing for problem, I think it was number 4. So I have hours to keep track of here, 1, 3, and 5. And some of you I heard did what I did and did 1, 2, and 3 hours by mistake, which messes stuff up. And then we have the resulting BAC. So the equation we were using was to take equals to start off with, negative 0.015 times the time, which happens to be in the cell next to me, so I just click it, plus we decided to round that number to 0.104. And so once I type the expression referencing the number next to it, I just hit enter, and then I can autofill to get the other numbers, which Google does automatically for me. If you were in Excel, Excel might not have done that automatically. You just click back on the calculation, grab that bottom magic button where your cursor changes to a plus, and then fill it down. And so those are the 3 numbers that we wanted in there. Now about those 3 numbers, let me get a screenshot of that so I can scribble on it.
Are you recording this? I'm sorry, you're going really.
I am recording it. And if I'm doing something fast, like you want to repeat it or write it down on a spreadsheet, just say, Parker, whoa, let me see that again. So
well,
is there something?
Recorded, I can watch the recording.
Okay, yeah, this will definitely be in the recording today.
All right, thank you.
Yeah. So here I have just that table of hours versus the BAC. And in the next question, we were asked, how is this changing per hour? Well, when I look at these 2 numbers, if I were to subtract these 2 right here, it dropped, right? So that means we lost some alcohol, and it dropped by 0.03 if you run that in your calculator. And the same thing happened here too. It dropped by another 0.03, okay? Now that happened over 2 hours, right? So we had an addition of 2 hours that had gone by each time. So what this table shows me is that every 2 hours, the BAC seems to drop by 0.03. And technically that's a percentage, so I'm going to throw the percent symbol there to speak more accurately about it. Now, but looking back at the question I'm asked next, the question says every hour, not every 2 hours, every hour. So now I got to rethink that change I saw on the table. Well, if it drops by 0.03 every 2 hours, I should be able to reduce that. So I want to take that 0.03% over 2 hours, there we go. And I want to divide the 2 into the numerator. So I want to know what is 0.03 divided by 2. So I could ask, I haven't used Desmos today. Let's do Desmos Scientific. Double check, if I take 0.059, subtract 0.089, missed a 0. There's my negative 0.03. And then I want to take that previous answer and divide it by 2, and I get 0.015.
You're froze.
Am I back? Can you see me?
Is he froze?
Oh, I think you might be having internet issues, or I am. Can anyone hear me? Hello? Is anyone there? Whose internet went out? Looks like mine, darn it. Let's pause the recording. Okay, so back, was I back here? I did the calculation.
No, you didn't do that on the calculator.
Okay, let's go back to the calculator then. So this is about where I froze up. So I just double checked on the calculator that the difference between the first two was negative 0.03. And then I'm just taking that and dividing by 2, and that gives me negative 0.015. So I'm just going to make a note of that and just double check its meaning on paper. So I often find it helpful to write things on paper so I can convince myself I'm doing the right thing before I start typing it into some box that's going to judge me. That was a negative there. So this is still negative 0.015. And this time, since I divided the 2 out, that means there's 1 hour in the denominator, and that's percent. So this new calculation tells me that every hour, BAC drops by 0.015. And so I think the box is waiting for me to put that in right there. So let's go look at that screen.
That's what we put, huh, Natalie?
Every hour, this student's BAC decreases. They're using decrease instead of drop. Now they have the percent symbol out there for me, so all I need to do is type the 0.015. So I don't need the negative because I got the word decrease and I got the percentage outside, so that looks pretty good there. And again, the reason I put you guys in groups is that way you guys convince each other that you're right before you go and push that button. The graph of this over time should look something like this. 0.89 is about there. And then what, 0.29 is probably about there. So your graph should have come down here. Couple things to note about this graph. I'm going to steal it into my page to scribble on.
That's what we did too, and it said it didn't have to be perfect.
Yeah, it didn't have to be perfect, correct. I just want to show you a couple of interesting things about this graph. So one thing is if I look to see where it hits right there, that number right there is that 0.104 that we calculated. Oops, miswrote that. 0.104 that we calculated in the beginning. Remember that calculation?
Mm-hmm.
That's the initial BAC. And then we used 2 of the points. So we had that 3 was at 0.059 here.
Yep.
And that calculation we just did where we saw that it dropped, right? We went down 0.03. That's a minus right there. Over 2 hours. That right there we call a slope. And you may have seen slopes before in another math class. Slope is your rise over your run. So my rise is actually a fall. So my numerator is the negative 0.03. And my denominator is that move that direction, positive 2. And we reduced that slope on the calculator and got negative 0.015. Question, have we seen this number somewhere else?
Yes, in the beginning of the lecture, you told us that was the how you started.
Yeah.
Negative 0.015 plus t plus 2.84n divided by w times g.
Yeah, so if we consider that equation that we entered for part 3, question number 3, this is the equation right here. The 0.014, right, that's my initial BAC, which is right here on the graph. And this negative 0.015, that's this slope here on the graph. So it turns out these numbers both appear on the graph. The 0.104 is easier to see than the slope though. And all this week and next week, we're going to be playing more with this idea of slope and initial values. So we're going to get to that when we look at the next prep in a minute. All right, I said I also wanted to look at question number 8. And wrong direction. I think I've got the right question. I think number 8, if I have the right question, asks when will the BAC be 0.08? Am I on the right question?
Yep.
Okay. So down here, how long will it take for this student's BAC to be 0.08%, 0.08%, the legal limit? Give your answer to 1 decimal place. I was hoping you can guess and check for sure on this by plugging into a calculator, but I just want to go over how I would solve this as an equation, which is a skill I'm hoping we'll all get better at. So they're telling me that the BAC, the B, is 0.08, and they're asking when, which translates in like algebra language as solve for the variable t. So the equation that I had a minute ago was that B equals negative 0.015 t plus that 0.104. I want to replace the B with that number right there. So I'm just going to erase it and fill in the 0.08. So once I fill that in for B here, I can now solve for t because t is just the only variable left. When you're solving an equation, you do things kind of backwards. Like if somebody told me what t is, I would multiply first and then add. So to solve, I do it backwards. So the first thing I should do here is subtract that 0.014. So I'm going to take this away from both sides.
Did you say you substitute the t with the 0.08?
No, the B is 0.08. So they told me the BAC is the 0.08, so I put that in place of the B, and now I'm going to solve for t.
Oh, okay.
And then my belief is the best first step is to get rid of this addition by subtracting it to the other side. So I'm going to subtract that 0.104. And I don't feel like doing that in my head, so I'm going to ask my calculator. What is 0.08 take away 0.104? And my calculator says it's negative 0.024. These two combine to be 0, right? 0 plus anything doesn't change it. So all that's left on the right side is the negative 0.015t. And then to cancel a multiplication here, I just divide by whatever is being multiplied, which is the negative 0.015. So I have to do that to this side too. And so I want to ask my, and I miswrote something. That is not a 5, that should be a 4. So I need to ask my calculator, what is this division right here? On the other side, right here, I have a number divided by itself, and a number divided by itself is always 1. 1 times t is just t. But I need a calculator for the other side. So I want to take that previous answer there and divide by negative 0.015. My calculator says 1.6 is the answer. Did anyone else get that?
Positive, right?
Positive, yeah, because a negative divided by a negative is a positive, correct?
Mm-hmm.
Did anyone else get 1.6?
I did.
Okay. So the next thing I want to ask myself, well, is it right? I totally could have screwed this up. I could have put that 0.08 in the wrong spot. I could have made a mistake on my calculator. I got clumsy fingers sometimes and push the wrong buttons. So I really should check this. And so to check it, I just want to put it back in. Check to see if it works. So go to the formula and calculate what is negative 0.015 times 1.6 plus that 0.104. So I'm just going to double check, does it really work? Because I'm a master at making mistakes in interesting ways. And I think I typed it right, and Desmos says, yeah, it's 0.08. Okay, so 1.6 hours later, a little over an hour and a half after having those 3 drinks, this person should be on the edge of the legal limit. So I would wait 2 hours just to be safe. All right, so I think that's a 1.6. There we go. The other answer, when will it be 0? That's pretty similar to what we just did, but we put a 0 over here to solve. And I'm going to leave that for you guys to try. It's the same steps we just did, except I'm going to have a 0 equals negative 0.015 t plus the 0.104. Okay, so again, the first thing we would do is subtract and then divide. I'll leave that as an exercise to you if you didn't get to it already. All right, so I'm gonna not answer that second one at the moment and jump on to the next page because I didn't get to address that with you guys, and I don't know if any of your groups did. So the next page gives us a different problem to look at, but it's related. This time we have a female student. And we have 110 pounds. And then instead of telling us how many drinks, she just plans to go home in 2 hours. And we want to play around with, well, how much could she drink to be safe is kind of the goal here. Now they cleaned up the equation for me here. So I just want to double check that it's right, but it probably is. So new page. So this is for the second problem, page 3, lesson 3.2. We've got a female, which means G is going to be the 0.55, and she was 110 pounds. So W is 110, and then this time we're given T is 2 hours, but we don't have, oops, hours, there we go. We don't know how many drinks. We're gonna play around with that. So the B equation is gonna go negative 0.015. This time we have T, so that goes here, plus the fraction, 2.84 times N. We don't know N yet. And then I have 110 for the weight times 0.55. And it looks like they put this into their calculator to clean it up, and they cleaned up that on a calculator. So double checking those numbers. If we take the 110 weight times the gender factor 0.55, we get 60.5.
Yep, and that's what they have.
And that's what they have there. And then if we double the 0.015, we get 0.03, which we saw on the previous page too. Okay. So it looks like they did a good job of cleaning it up. Sometimes I don't take things for granted. And then based on this equation, we're supposed to build a new table where we plug in, okay, what happens if she has 1 drink? What's her BAC gonna be? And that's always 2 hours later for this equation. What happens if she has 3 drinks? What's her BAC gonna be? In this scenario, determine how many drinks she can have so that her BAC remains less than 0.08. So I'm gonna skip down to this question here. So question, how many drinks for BAC of less than 0.08. Double check that I read that right. How many drinks can she have so her BAC remains less than? Okay, so for ease of calculation here, I'm just gonna set it equal to 0.8 and then go back and think about it. So kind of like we did on the previous page, I'm just gonna put 0.08 in place of the B on that side, and then rewrite the rest of the equation. And we could play around with this by just plugging in different numbers for n to see what happens, right? We could do a guess and check, or we could try and solve this. So I'm going to try and go through the steps to solve this. And for most equations that look kind of like this, it's usually easier to get rid of things that are added or subtracted first than it is to get things that are multiplied and divided. So on the next page, I'm going to start my work. I'm going to target that 0.03 first.
What's that under the 2.84? Was that a 60?
60.5
Oh, okay.
is what was given, and we calculated that.
That's right. Yep, I remember. Thank you.
Yeah. So 0.08 equals negative 0.03 plus that 2.84. I'm just rewriting it for the moment, so I have some room to work. And so I have this added on number, the 0.03. It's a negative, so to get rid of it, I'm going to add a 0.03, because if you take a negative and add it to the same positive, that adds to 0, right? So the whole point is that's nothing. But I got to do the same thing on the other side. So on this side, I also have to add the same 0.03. And let's see, 8 plus 3 on a good day is 11, so that should be 0.11. That's a 0, so all that's left on the other side is that fraction. So I'm going to rewrite this, 0.11 equals 2.84n over 60.5. Now I have a few options to go on this side. I could view this as the 2.84 over 60.5. It's just a fraction, so I could deal with it as a fraction. Or I could deal with it as I have a multiplication to deal with and I have a division to deal with. So I'm going to take the second route here. I want to get that 60.5 out of the denominator. So to do that, I want to multiply by 60.5 on both sides. And the point on the right here is that if I take a number and divide it by itself, so 60.5 is in the numerator, 60.5 is in the denominator, a number divided by itself is 1. 1 times anything doesn't change much. So on the right side, I just have the 2.84n. And then I got to use my calculator for the other side. So I've got that 60.5 times 0.11 gives me 6.655.
Six point what?
6.655.
Okay, thank you.
Double check that I typed it right. 60.5 times 0.11, yep, 6.655. Last step is to divide to get rid of this multiplication here. And so I'm going to divide by 2.84. And again, a number divided by itself is 1. 1 times n is n. What do we get? Divide by 2.84. I get 2.343. I'm going to go for 3 decimal places for now and then think about it. It's 2.343. So 2.343. Another thing is I'm going to put a wavy equals sign here because the wavy equals sign reminds me that I rounded. get that? All right, so the original question was, how many drinks could she have so that the BAC was at least, no, it was less than, I want the BAC to be less than 0.08. Now, if she has more drinks, the BAC will be greater. So she could have 2 drinks. She could have 2 1/4 drinks. She could have 2.3 drinks. If she has exactly 2.343, that, let's see, is that rounded up or down? That is rounded down compared to the rest because I dropped off that extra stuff. Okay, so if we could actually measure a drink to the nearest thousandth of a standard drink, then to 3 decimal places, that's how much she could have. So let's see what the question says here. Since she could finish only part of a drink, give your answer to 1 decimal place. Okay, so to 1 decimal place, we would say 2.3. And she could have a little bit more than that, but we want to be safe. And let's double check to make sure that's correct. So let's check to see if it's true that N can be 2.3 in drinks and will still be under the legal limit. So to check that, we just plug into her equation, and her equation said take the negative 0.03, add that to 2.84 times the number of drinks, I claim that's now 2.3, and divide by 60.5. So I'm going to plug this exactly as I see it into my calculator, and because I don't want to hit the button and get it wrong, right? I want to be able to check. So negative 0.03 plus fraction, where's the fraction button? I think I just hit divide on this calculator. There we go. 2.84 times 2.3, I was guessing from the answer above, divided by 60.5. So I highly recommend you try this on your calculator too, because you got to be the master of your own calculator. Hit enter, and look it, I'm a little bit under 0.08. You can read that. Oh, that was interesting. I tried to blow it up. Yeah, so I'm a little under 0.08. Looks good. I think I did it right. Oof, that was a lot of work.
Mhm.
Other things we're asked to do on this page, based on the table above, which you may or may not have done yet, we're going to plot those 2 points and see what it looks like. So we should find it's as time, let's see, what are we doing here? Oh, the more drinks she has, the more drunk she gets. So this should be going uphill because we're increasing the number of drinks, N. And that's the end of this lesson. So I'm just going to pause here, let you, for a few minutes, let you work on whatever you need to. And then I want to talk about the homework and the prep. We've got about 10 minutes of official class time left.